I am Ankur Kumar Yadav. Today in this video I will be showing you how to develop an Android application for BeagleBone Black that can use GPIOs of BeagleBone. So let's proceed. This is the setup that I have arranged for this demonstration. So here you can see that I have an LED and a button attached to the BeagleBone Black. So this LED is attached to the 11th pin of P9 header, that is GPIO 30, and this button is attached to the 27th pin of P9 header, that is GPIO 115. So let me show you this arrangement. So here you can see that I have my BeagleBone, then I have a LED and a button attached to it. This LED is attached to the 11th pin of P9 header, and this button is attached to the 27th pin of P9 header. This is the screen that is showing the Android OS running on BeagleBone Black. So this is the setup that I am using for the demonstration. So let's proceed towards the steps of actually creating the Android application. So these are the steps that we will follow for creating our application. First of all, we have to create new Android project in Eclipse. This is a pretty simple task, so I have already done that. So you can see that I have created a new project named GPIO. So this is the app repo. This we will be using for creating our application. Next step is to copy and paste the JNI folder from BBB Android Hall to your app directory. So what is this BBB Android Hall? So this repository contains all the native support for building our Android application. This code was developed by me for this GSOC project. You can find this code on GitHub. So this is the link for this repo, github.com/ankureyadav/bbb Android Hall. You can see that here there is a folder JNI. We have to copy this folder in our application directory. So I have developed this code from the code of Pact Publications that was developed by Android Henderson for his book that was published by Pact Publication. Let's hit the download zip button and download this repo. I have already done that, so I'll move to towards the next step. Let me show you the repo. So you can see that I have this repo, and this repo contains cape JNI folder. We have to copy this JNI folder in our workspace GPIO. So let's do that. So just copy the JNI folder in your app directory. Now when you will see what it contains, then you will see that it contains some C files that act as the interface for accessing the peripheral of BeagleBone. Next step is to change the android.mk file and also the application.mk file. You will see that there is a temp folder. In this temp folder I have two files, android.mk and application.mk. You have to simply copy these two files in your JNI folder. So actually this android.mk contains the commands for creating the binary executable that can directly be run on BeagleBone Black. It can be pretty useful when you want to create a quick application before creating an Android project. But here we will be demonstrating the Android project, so I will copy these two files. This android.mk contains the configuration for creating the library that can be used in our Android app. So just copy these two files. So now we have successfully replaced these files. Next step is to change java underscore class underscore path macro in jni underscore wrapper.c. So just open this file. So here you can see that I have a macro called java underscore class underscore path. So what is this? So this is actually the path to my main activity. So let me show you. So in your project you can see that src, in this src you have com.pack.gpio, in this we have main.java, main activity.java. so this is the path that we have to write there. So actually I am using the default GPIO app that was provided by packed publication code. Just I have replaced the library. I will be using BBB Android HAL. So you have to just write the path java underscore com underscore packed underscore GPIO underscore main activity. So this will be replaced in all places where macro is written. So what actually happens is whenever your Android project calls a function, then it actually calls the function from this jni underscore wrapper dot c. So like if this file calls OpenGPIO, then it will actually call the OpenGPIO of this function, and this in turn will call the OpenGPIO of the native C code. So this is the flow. So after doing that, we have to load library and define native function prototypes in your main activity.java and make your application by using native function calls. So next step is linking your library in your Java code. So you can see that I have linked the library system.load library BBB Android HAL. So and after that I have created some prototypes of the native calls. So these functions will be calling the JNI wrapper functions, and that functions will be calling the native C functions. Now let's create the library. So first of all, just move in your workspace. So here you can see that I have my JNI folder. Move to that JNI folder. Then just call the ndk build from this folder. So here you can see that I have my Android SDK setup at home Android. I am calling android.build from this directory. When I hit enter, then it will build the library. So you can see that my library is built lib bbb android hal.so, and it is stored at libs slash armeabi slash bbb android hal.so. so let me show you that. So I have the libs folder and obj folder created. Now my library is ready to be used in Android application, but before that I have to export the GPIOs in BeagleBone so that my application can use that. So let's do that. So just find the devices attached to your PC. Now I'll move into this shell. Let's move towards the sys/class/GPIO. Now I have to export the GPIO. So export 30 echo 30 port echo. So you can see that I have exported two GPIOs. Now I'll move into the GPIO folder. Here you can see that we do not have permissions to change the value from users, so we have to give the permission. So let's do that. chmod. Now our Android application will be able to change the value. Also we have set up GPIO number 30 for output, so we have to change the direction because by default it is in input mode, so just change the direction. So now you can see that direction is in output mode. Actually we can change the value from here also, so let's see what happens when we change the value. So let me show you. So you can see that currently LED is not growing, but when I press enter, now LED is glowing. So let's change this value. So when I press enter, so LED is off, again on, off. Similarly we have to change the permissions for accessing our button, so just change the permissions. It is by default in input mode, so we need not to change the direction. Here also you can see the value. So currently it is on because it is pressed, button is pressed. When I press it again, then it should be off, so you can see 0. Again when I press the button, then you can see it is 1. So using these steps you can turn on off LED, use GPIO from the shell, but we have to use GPIOs using the Android application. So let me show you that. So here you can see that I have a code ready for the demonstration. So these are my native function calls that I'll be using for calling the GPIOs. Here you can see my application, how it looks. So I have a poll button state that will poll the button state if it is on or off. Then I have a turn on and turn off light button, so that will turn LED on and off. Here you can see that this is, so on click poll status, so it will read GPIO 27 from header 9 and it will return the status if it is on or off. Similarly when I click on button light on, then it will send a 1 to the value of 11th pin of 9 header and it will be on. Similarly for off. Let's execute this application. So now you can see that here is my application running on BeagleBone. So let me show you the current status of LED. So LED is currently off. When I press turn on LED, then you can see that LED is on. Again I am pressing turn off LED, LED is off. Again when I press on, then it is on. Button, for button, when I click poll button status, then currently it is on. When I press the button, off. So now if I press state, it is off. Again when I press the button, now I poll the button state, again it is on. So you can see that this application is working. Now you can think that we have every time when we create the application we have to give permissions to the GPIO. but actually we can do it at runtime also. So let's do that. So let me so here you can see that there is a file called init.generator.rc. so we have to put all our permissions and everything in this file. So whenever our application our Beagle is booted, it automatically runs through these commands. So let's do that. So just pull that file. So adb pull, then we have to pull this file. Now just modify this file. So whatever we did, we have to enter those command here. So just do that. Write GPIO / export 30. Similarly we have to export 115. Now we have to change the direction of GPIO 30. So just do that. Now we have to change the permission. Now just push this file into the directory, into the system again. So just into the root directory. I have pushed that. Just give the permissions so that root can execute this, root user can execute this. Now it is set for next boot. So just reboot your device. So let's wait for some time while it is boot. So let's check if GPIOs are exported. So go to sys class GPIO. So you can see that GPIOs are already exported. Now you can see the permissions also. So you can see that we have permission to be executed from the Android app. Now I'll be running the Android app that is already stored in the system. So you can see here, let me go to the app. So when I click turn light on, so you can see that line in on, then when I click turn light off, then it is off. So it's working. So this is it for this application. You can find this code on my GitHub repo. So all the sample codes will be available at ankur.yadav/demo apps-bbb android. So this is the sample application that I was showing you. You can download the code from here. Thank you.